All right, so let's just describe these last two fucking idiotic experiments. All right, so I don't remember the first experiment exactly what the numbers were. 3.7 comes to mind, or some kind of silly number.
So now numbers are silly? When you measure a certain experimental result, the number is silly? Oh, I know. It's a silly number because it didn't came out your way. That's how childish you are. Pathetic human being you are.
And his argument is he's supposed to be getting, let's just say it's 3.9, and then we'll call the other number he gets 3.2. All right, so the silliness of his argument is he's got a quantity, this 3.2, and he's going to say this other thing, changing the velocity or measuring it with twice the mass or some other circumstance is going to be twice the energy. And instead he gets this number. Nowhere near twice the energy, right? 20% versus 100%.
What you didn't realize was that the nail was already penetrated a certain amount in the foam to start with. I had to do this, otherwise the nail would just fall over, obviously. I can't just put the nail on the foam, I have to push it a certain amount into the foam to make sure it will stand still. You can see in the image that the 0 point, which is aligned with the surface of the foam, is not at the bottom of the nail. However, I did measure it each time from starting from the bottom of the nail. What I should have done is measuring the initial penetration length, and then subtracting that length with the total penetration length. But right now, I have no interest in repeating this experiment.
All right, and then this one, there's only, let's say, we'll call it 2 centimeters, okay, even though it's probably less than that, 20 millimeters. So you have 20 millimeters of motion.
I don't know what you mean with 2 centimeters, but the dropping height was 5 centimeters. I literally said and showed it in the video. Here I dropped the 4 mass from one height. In this case, one height is 5 centimeters. Learn to pay attention, Gary.
And he gets results of 10.2 and 10.9. Now in this case, they're supposed to be exactly the same. So in this case, this is the 4 pounds drop 1 foot, and this is the 1 pound drop 4 feet. Okay, those are supposed to be the same. Now there's only 20 millimeters to work with here, so obviously this is a gigantic miss. I mean, it's 40% too much energy here, 40% too much. All right, and from my perspective, right, it's 140% off, because obviously this is supposed to be twice as much as that. So you got a number that, yes, is way off my number, but it's way off his own number.
Gary, you really suck at paying attention. The one mass was dropped from 4 times the height and reached the 10.95 centimeters mark each time. Here is a one mass dropped from 4 times the height, so I drop it from 32.2 centimeters. As you can see, the maximum compression reaches the 10.9 or 10.95 centimeters mark. The 4 mass was dropped from one height and reached the 10.9 centimeters each time. Here I drop the 4 mass from one height. In this case, one height is 5 centimeters, so I drop it from 17.2 centimeters. As you can see, the maximum compression always reaches the 10.9 centimeters mark. So it was the same for fuck's sake, you goddamn time waster. Then I dropped the one mass from 16 times the height, so 4 times as fast, and that reached the 10.2 centimeter mark each time. So here, I drop the one mass from 16 times the height, so I drop it from the 92.2 centimeter mark. As can be seen, the maximum compression always reaches the 10.2 centimeters mark. Your claim is that the one mass dropped from 16 times the height is the same as the 4 mass dropped from one height. And those were clearly not the same, you moron.
So, I mean, how much can it be taken seriously? And if you just watch the experiment, it's quite obvious that the one mass is going a hell of a lot more than twice the velocity, because for whatever reason, like I said, you can blame the wooden blocks. Look,
so you think the velocities are incorrect, and of course, you think it's an absolute crap experiment once again? Isn't it your prediction that when a one mass going twice as fast should produce twice the amount of spring compression than the one mass going half as fast? Well, guess what? That's what happened in my experiment. I dropped the one mass from 4 times the height, so twice as fast, and I dropped it from 16 times the height, so 4 times as fast. This is in fact doubling the velocity. Here you can see the spring without weights on top of it, as viewed from the slow-motion camera. It reaches the 11.7 centimeters mark. The one mass 4 height reached the 10.9 centimeters mark, so 8 millimeters of compression. The one mass 16 height reached the 10.2 centimeters mark, so 15 millimeters of compression. 15 millimeters is close to twice the amount of spring compression. This means that my experiment proves your prediction right. Twice the velocity equals twice the amount of spring compression. So it's a good experiment, right? Or is it just a coincidence once again?
And so he filmed it again at a shitty angle. So the angle is from below. He's filming a ruler from below the ruler up, which is really illogical. Then using this wooden ball and then putting metal weights on top of it, who knows what sense that makes. But anyway, the whole idea of this guide was...
Here we go again, nagging about little details, letting us change the setup over and over again, hoping it will one day come out your way. But nope, Gary, it doesn't. You are simply wrong, and too much of a coward to accept it.